Right, so we've got to convert this to a form where we can easily find what the coordinates and the radius of the circle are. Right, if I get the x's together and get the y's together, plus 195 equals 0. Now if I complete the square on these, so x squared minus 20x, if we say it's x minus 10 all squared, that gives us the x squared minus 20x, but it also gives us an extra plus 100, which we don't want, so we take that away. Plus y, and the same thing with y minus 12 all squared, take away the 144, and we still need to add on 195 equals 0. So then we have x minus 10 squared plus y minus 12 squared is going to equal 100 plus 144 is 244 minus 195, which I think comes to 49, which is the same as 7 squared. Okay, so part A, the coordinates of the point M, which is the centre, we can read straight away from a formula. It's going to be 10, 12. 10, 12. And the radius is going to be 7. So radius equals 7. There we go. So this is our working out for part A, and I've written the answers there in red. Right, next part. N is a point with those coordinates, and we want the length of the line MN. So we use Pythagoras, and MN squared is going to be the difference in the y coordinates from M to N squared, plus the difference in the x coordinates squared. So M is the point 10, 12, N is the point 25, 32. So the difference in the y coordinates is going to be 32 minus 12. And the difference in the x coordinates is going to be 25 minus 10. And we do that and we get 20 squared plus 15 squared, which is 400 plus 225, which comes to 625, which means that MN is the square root of 625, which I think is 25. Done that. Right, now part C. The tangent to C at a point P on the circle. Now we don't know what point P is yet, and I don't think we actually need to find what point P is, because if I draw a diagram, a little sketch, so there's a circle. Now our midpoint is the point M, which is the point 10, 12. It then gives us this other point N, which I'll say is somewhere up here. N, and N is the point 25, 32. 25, 32. And we've already worked out what the length of the line MN is. So if I draw that line in, there we have it, and we've already actually found what that line is. And then it tells us that the tangent to the circle at some point P goes through the point N. So what that means is, if I draw a tangent like that, okay, the tangent goes through the point N, and that point there is our point P. And remember that we know that the line from the centre of the circle to the point P, or in other words the tangent, we know that that must actually be at right angles. So we can draw a right angle triangle. Now we know the line MN is 25 long. Okay, so that's 25. We know that from M to P is just the radius, and we know that that's 7. So I think you can see that just using Pythagoras will enable us to find the length of the line NP without even knowing what the coordinates of P are. And we can just say that NP squared is just going to be equal to 25 squared minus 7 squared. And 25 squared is 625 minus 7 squared, which is 49, and that comes to 576. So NP is the square root of 576, which is 24, and we've done it.